Electric versus gasoline. The ultimate showdown. Which car truly drives into the future? Electric car. There is a growing number of electric sports cars on the market as the automotive industry increasingly focuses on electric mobility and performance. Below, I present some of the most well-known electric sports cars available on the market as of my knowledge cut-off date in September 2021. Please note that model availability and technological developments may have changed since then. Tesla Roadster. Tesla, a pioneer in the electric car industry, originally produced the Tesla Roadster, which was manufactured from 2008 to 2012. An updated version of the Tesla Roadster was announced for the future, known as the second generation Roadster, which is expected to offer remarkable range and acceleration. Rimac C2. The Rimac C2 is a high-performance Croatian electric sports car, engineered with impressive specifications and cutting-edge technology. With an expected top speed of over 400 km per hour and acceleration from 0 to 100 km per hour in under 2 seconds, the C2 is a stunning example of electric vehicle performance. Porsche Taycan. The Porsche Taycan is Porsche's first all-electric vehicle, bringing the performance and luxurious design expected from the brand to the world of electric mobility. With various model variants and range options, the Taycan offers a wide range of performance capabilities. Audi e-tron GT. The Audi e-tron GT is another electric sports car manufactured by Audi. Based on the same platform as the Porsche Taycan, the e-tron GT offers sporty performance and signature Audi design. BMW i8. Although not a pure electric vehicle, the BMW i8 deserves a mention as a plug-in hybrid combining an electric powertrain and a combustion engine. The i8 offers a futuristic design and impressive performance. Lotus Evija. The Lotus Evija is the first all-electric hypercar from the legendary British sports car brand Lotus. With an incredible output of over 1,900 HP and a stunning design, the Evija demonstrates that electric mobility and high performance can go hand in hand. Neo EP9. The Neo EP9, developed by the Chinese electric vehicle manufacturer Neo, is an electric sports car with record-breaking performance. The EP9 has set several speed records for electric vehicles on various racetracks and demonstrates the potential of electric mobility in motorsports. Aspark Owl. The Aspark Owl is a Japanese electric sports car known for its impressive acceleration. Designed to accelerate from 0 to 100 km per hour in under 2 seconds, the Owl is among the fastest production cars in the world. Pininfarina Battista. The Pininfarina Battista is an exclusive electric sports car developed by the Italian design firm Pininfarina. With over 1,900 HP and a luxurious interior, the Battista embodies elegance and performance in an electric vehicle. Mercedes-Benz EQS AMG. The Mercedes-Benz EQS AMG is a sporty version of Mercedes-Benz's electric flagship, the EQS. With improved performance, a sports suspension, and a special design, the EQS AMG demonstrates that electric mobility and sportiness can go hand in hand. This list is just a selection of the many electric sports cars that have been launched or announced in recent years. Electric mobility undoubtedly has the potential to revolutionize the sports car industry by combining high performance with zero emissions driving. It's likely that many more exciting and powerful electric sports cars will enter the market in the coming years. Electric cars. An introduction. Electric cars are an emerging technology that focuses on the use of electric motors to propel vehicles. Unlike conventional internal combustion engines that burn fossil fuels like gasoline or diesel, EVs use a battery as their power source. This battery is charged externally, usually through a wall outlet or charger, and then used to power a motor that moves the vehicle. The idea of electric cars is not new, and prototypes and developments in this field have been around for many years. However, in recent years, the technology has reached a turning point, and electric cars are increasingly being viewed as a serious alternative to conventional cars. A major advantage of electric cars is their environmental friendliness. Because they don't burn fossil fuels, they produce no exhaust fumes and thus contribute less to air pollution and climate change. Instead, the electricity used to charge the battery is often generated from renewable sources such as solar, wind, or hydroelectric power plants, further reducing their environmental impact. In addition to being environmentally friendly, electric cars also have several practical advantages. They are generally quieter than combustion engine vehicles and are easier to maneuver in cities due to their smaller size and maneuverability. Electric cars also often have faster acceleration and can accelerate faster than conventional cars. However, there are also some challenges associated with using electric cars. For example, electric cars generally have a shorter range than combustion engine vehicles, meaning they can't travel as far before needing to be recharged. Charging can also take longer than filling up a conventional car, although fast charging options are now available. Another obstacle to electric cars is the purchase price. Compared to conventional cars, electric cars are generally more expensive, although prices are gradually decreasing as technology advances and more cars come onto the market. However, electric cars can be cheaper to run because they generally require less maintenance and electricity is often cheaper than gasoline or diesel. Another challenge for electric vehicles is the limited availability of charging stations. While charging at home or work is an option, there are still not enough public charging stations to meet the needs of all electric vehicle owners. This can lead drivers to worry about not having charging options while on the road, especially on longer trips. How do electric cars work? Electric cars are a relatively new technology in the passenger car market and have gained increasing traction in recent years. They are an important element in efforts to reduce vehicle CO2 emissions and mitigate the environmental impact of transport. The basic principle of electric cars is simple. They use electrical energy stored in a battery to power an electric motor, which drives the car's wheels. In contrast, a conventional car uses an internal combustion engine to generate mechanical energy that propels the car. The internal combustion engine uses fossil fuels such as gasoline or diesel, which are burned to produce the necessary energy. The electric motor of an electric car consists of a stator and a rotor subassembly. The stator is the stationary part of the motor and consists of a series of copper coils wound around an iron core. The rotor, on the other hand, is the moving part of the motor and consists of a magnet mounted on a shaft. When an electric car is started, the current from the battery is transferred through the cable to the stator in the electric motor. The stator creates a magnetic field that drives the rotor. Because the rotor is a magnet, it is attracted by the stator's magnetic field and begins to rotate. This rotation ultimately drives the car's transmission and wheels. One of the most important components of an electric car is the battery. The battery stores the electrical energy that powers the car and supplies it to the electric motor when needed. The battery consists of a number of cells connected in series. Each cell contains electrodes consisting of a positive and a negative material separated by an electrolyte solution. When the car is charging, electricity flows through the cable into the battery. The current flows through the electrolyte in the cells, charging the electrodes. The charge is stored until needed to power the electric motor. When the car is moving, the electricity from the battery flows back into the motor, and the cycle begins again. Battery technology has made significant advances in recent years, resulting in electric cars that now have a longer range and can be charged faster than before. Most electric cars can now achieve a range of 200 to 300 kilometers per charge, which is sufficient for everyday use. However, there are also electric cars with a range of over 500 kilometers that are suitable for longer journeys. Electric cars have many advantages and disadvantages to consider. Here are some of the most important points. Advantages of electric cars. Environmental friendliness. Electric cars do not emit harmful emissions during operation and are therefore more environmentally friendly than conventional cars with combustion engines. Cost savings. Electric cars can be cheaper to run than petrol or diesel cars because they require less maintenance and the price of electricity is often lower than that of petrol or diesel. Quiet operation. Electric cars are generally much quieter than cars with combustion engines, making them more pleasant to drive. Subsidies. In many countries, there are currently government subsidies for the purchase of electric cars, which can reduce the purchase costs. Regenerative brakes. Electric cars often have regenerative brakes that recover energy during braking and can thus increase the car's range. Disadvantages of electric cars. Limited range. Electric cars generally have a shorter range than conventional cars, which makes planning longer journeys more difficult. Longer charging times. Charging electric cars generally takes longer than refueling with petrol or diesel and requires appropriate charging infrastructure. Higher purchase costs. Electric cars are generally more expensive than cars with combustion engines, although operating costs can be lower. Limited availability. There are currently fewer models and fewer electric cars on the market than cars with combustion engines, which can limit choice. Uncertainty regarding battery life. Although battery technology is improving, battery life is still an uncertainty factor that can increase the cost of operating electric vehicles. It is important to carefully weigh these advantages and disadvantages and consider individual needs and preferences before deciding for or against an electric car. There are different types of electric cars, each differing in their drive technology and intended use. Here are the main types of electric cars. Battery electric vehicles BEVs. BEVs are powered solely by a battery and do not have an internal combustion engine. The battery must be regularly recharged to operate the vehicle. BEVs typically have a limited range, but they are very environmentally friendly and require less maintenance than cars with internal combustion engines. Plug-in hybrid vehicles PHEVs. PHEVs have both an electric motor and a combustion engine that uses either gasoline or diesel. The electric motor is powered by a battery that requires regular charging, while the combustion engine is switched on when needed. PHEVs have a longer range than pure electric vehicles, but depending on the usage profile and charging behavior, they may not always have the optimal environmental footprint. Range extender electric vehicles REEVs. REVs also have an electric motor and battery, but use a small gasoline or diesel engine to recharge the battery while driving. The engine serves only to extend the car's range and not as its primary propulsion. Fuel cell vehicles FCEVs. FCEVs use hydrogen to generate electricity and power the vehicle. FCEVs have no batteries and produce only water vapor while driving. FCEVs have a long range and are very environmentally friendly, but the availability of hydrogen refueling stations is currently very limited. Each type of electric car has its own advantages and disadvantages, depending on the user's requirements and preferences. Charging electric cars involves plugging the car into a charging station or power outlet to recharge the battery. Here are the basic steps to follow when charging an electric car. Check the battery charge level. Before charging your electric car, you should check the battery charge level. Most electric cars have a display in the cockpit that shows the current charge level. Choose the right charging infrastructure. Depending on the type of electric vehicle and the charging location, there are different types of charging stations and plugs that can be used. There are public charging stations located on the side of the road, in parking lots, or rest areas, as well as private charging stations that can be installed at home or at work. Depending on the type of charging infrastructure available, you will need to carry the appropriate cables and adapters. Connect the electric car. To charge the electric car, connect the charging station cable to the car. Most electric cars have a charging socket located either at the front or rear of the car. Some charging stations offer the option of activating the cable via an app or RFID card. Wait until the electric car is fully charged. The charging time depends on various factors, such as battery capacity, the type of charging station, and the battery's charge level. There are different types of charging stations with different power ratings, which can shorten the charging time. Most public charging stations have a display that shows the car's current charge level. Once the car is fully charged, the charging process stops automatically. Charging electric cars requires some planning and organization, but most electric cars have sufficient range to cover daily needs and only occasionally require longer charging times on long journeys. The range of electric cars varies depending on the model, battery capacity, driving conditions, and driving style. However, in general, electric cars have a shorter range than vehicles with combustion engines. Here are some examples of the range of some of the most popular electric cars. Tesla Model S, up to 663 kilometers, according to WLTP standard. Tesla Model 3, up to 614 kilometers, according to WLTP standard. Audi e-tron, up to 436 kilometers, according to WLTP standard. Porsche Taycan, up to 484 kilometers, according to WLTP standard. Nissan Leaf, up to 385 kilometers, according to WLTP standard. Volkswagen ID3, up to 541 kilometers, according to WLTP standard. It's important to note that the range of electric cars depends heavily on driving conditions. Higher speeds, steep inclines, air conditioning, or heating can increase energy consumption and thus reduce the range. Appropriate planning of charging times and charging infrastructure is therefore crucial to ensure you have sufficient range at all times. The cost of electric cars can vary greatly depending on the model, battery capacity, and features. However, In general, electric cars are often more expensive than vehicles with combustion engines due to the higher cost of battery technology. Here are some examples of the costs of some of the most popular electric cars in Germany. Volkswagen ID.3, from approximately €33,000. Tesla Model 3, from around €41,000. Renault Zoe, from around €23,000. Audi e-tron, from around €66,000. Porsche Taycan, from around €90,000. BMW i3, from approximately €38,000. It's worth noting that electric cars can often receive government subsidies to lower the purchase price. In Germany, for example, there's the Umweltbonus subsidy, which provides up to €6,000 toward the purchase of an electric car. In addition, electric cars can be more cost-effective in the long run than vehicles with combustion engines due to their lower operating costs, as they require less maintenance and have lower energy costs. The future of electric cars looks promising, and it's safe to assume they will play an important role in future mobility. There are several reasons for this. Climate protection. Electric cars have a significantly better CO2 balance than vehicles with combustion engines and can therefore help combat climate change. Technological progress. Battery technology and electric motors are constantly evolving, leading to longer ranges, shorter charging times and lower costs. Political support. Many governments promote the purchase of electric cars and invest in the expansion of charging infrastructure. Market development. The market for electric cars is growing steadily and more car manufacturers are bringing new models onto the market. Electric cars are expected to become increasingly widespread in the future and will also be seen more frequently on the road. Further developments in technology and infrastructure will also contribute to making electric cars increasingly attractive to consumers. Combustion engines. Cars. Internal combustion engine cars are vehicles powered by an internal combustion engine that uses gasoline or diesel as fuel. The internal combustion engine generates energy by igniting a mixture of air and fuel in a combustion chamber. This energy is then transferred to the wheels via the transmission and driveshaft to move the vehicle. Internal combustion engine cars have been the most common type of vehicle for many decades and come in a wide variety of sizes, shapes, and functions, from small city cars to large trucks. They are generally somewhat less expensive than electric cars, but also have higher operating costs due to higher fuel and maintenance costs. However, it's important to note that internal combustion engine cars also have a worse environmental impact than electric cars, as they emit more pollutants such as carbon dioxide, nitrogen oxides, and particulate matter into the atmosphere. For this reason, the transition from internal combustion engines to electric cars is seen as an important step in the fight against climate change. Internal combustion engine cars work by burning fuel in an engine, which then converts the energy into mechanical power to propel the vehicle. Most cars have a gasoline engine that burns gasoline or a diesel engine that burns diesel. The functioning of a gasoline engine is as follows. The fuel and air are mixed in the engine, with the amount of fuel controlled by a carburetor or fuel injection. The mixture of fuel and air is ignited in the engine's cylinders by a spark plug, creating a small explosion that pushes the piston down. The piston is attached to a crankshaft, which rotates and converts the movement into a rotary motion. The rotational movement of the crankshaft is transmitted through the transmission and drive shaft to the wheels to move the vehicle. A diesel engine works in a similar way, but instead of a carburetor or fuel injection, an injection system injects diesel fuel into the cylinder, where it is ignited by the heat of the compressed air. While combustion engine cars are widely used, they also have a worse environmental impact than electric cars, as they emit more pollutants such as carbon dioxide, nitrogen oxides, and particulate matter into the atmosphere. For this reason, electric cars are considered a more sustainable alternative. Here are some advantages and disadvantages of combustion engine cars. Advantages: reliability. Internal combustion engine cars have been on the market for many years and have proven to be reliable vehicles. There are a large number of service stations and workshops that can perform maintenance and repairs. Flexibility. Combustion engine cars generally have a longer range than electric cars and are easier to refuel. Fast charging. Combustion engine cars can be refueled in just a few minutes and are immediately ready for use again. Disadvantages. Environmental impact. Combustion engine cars emit large amounts of pollutants such as carbon dioxide, nitrogen oxides and particulate matter, which contribute to environmental pollution and accelerate climate change. High operating costs. The fuel and maintenance costs of internal combustion engine cars can be high over time. Noise and vibration. Internal combustion engines can be loud and vibrating, which can lead to an unpleasant driving experience. Dependence on fuel. Internal combustion engine cars are heavily dependent on the availability of fuel, which can be problematic in times of crisis or shortages. Overall, there are advantages and disadvantages to combustion engine cars, but due to environmental concerns and higher running costs, electric cars are considered a more sustainable alternative. There are different types of internal combustion engine cars, which can be categorized according to their purpose and construction. Here are some of the common types. Sedan. A sedan is a body style for passenger cars that typically has an enclosed passenger compartment and a separate trunk. Sedans are often equipped with a gasoline or diesel engine and are used for daily use as well as business trips. Station wagon. A station wagon is a body style for passenger cars that typically has a larger cargo area than a sedan. Station wagons are often equipped with a gasoline or diesel engine and are used for transporting people and luggage. Sports car. A sports car is a fast and powerful vehicle with an aerodynamic body, often used for racing and recreational driving. Sports cars can be equipped with either a gasoline or diesel engine. Off-road vehicle. An SUV, sport utility vehicle, is a four-wheel drive vehicle with high ground clearance designed for use on rough terrain. SUVs can be equipped with either a gasoline or diesel engine. Subcompact. A subcompact is a small and maneuverable car, usually equipped with a small gasoline or diesel engine. Subcompact cars are often affordable and well suited for city driving. There are many other types of internal combustion engine cars, such as convertibles, coupes, vans and pickup trucks, each with its own characteristics and uses. Internal combustion engine cars can run on various types of fuel, the most common being gasoline and diesel. Here are some of the types of fuel that can be used in internal combustion engine cars. Gasoline. Gasoline is a fossil fuel derived from crude oil. It is often used in gasoline engines, which use an ignition spark to burn the fuel and generate energy. Diesel. Diesel is also a fossil fuel derived from crude oil. It is often used in diesel engines, which operate without spark plugs and ignite the fuel through pressure and heat. Ethanol. Ethanol is produced from plants such as corn, sugar cane, or cellulose and can be used as a fuel in gasoline engines. Ethanol can be used as a pure fuel or in combination with gasoline. Biodiesel. Biodiesel is made from vegetable oils or animal fats and can be used as a fuel in diesel engines. Biodiesel can be used as a pure fuel or in combination with diesel. Liquefied petroleum gas, LPG, used as an alternative to gasoline or diesel. LPG is a mixture of propane and butane. It can be used in gasoline engines or specially converted diesel engines. Compressed natural gas, CNG. Natural gas is another alternative to gasoline or diesel and consists of methane. It can be used in specially converted gasoline or diesel engines. There are also other alternative fuels such as hydrogen and electricity that can serve as an energy source in fuel cell vehicles and electric cars. Internal combustion engine vehicles emit various types of emissions during operation. The most important ones include carbon dioxide, CO2. This gas is produced when fuel is burned in the engine and is an important greenhouse gas that contributes to climate change. Nitrogen oxides, NOx. These compounds are formed from nitrogen and oxygen in the air at high temperatures and pressures in engines. They contribute to air pollution and can harm human health. Hydrocarbons, HC. These compounds are a group of organic compounds that also contribute to air pollution and pose a potential cancer risk. Carbon monoxide, CO. This colorless, odorless, and tasteless gas is produced by incomplete combustion and is toxic to humans. Particulate matter. Small particles resulting from brake and tire wear and from the combustion of fuels can enter the air and affect people's health. The amount of emissions emitted by an internal combustion engine vehicle depends on various factors, such as the type of fuel, the age of the vehicle, and the driver's driving style. However, strict emissions regulations exist in many countries and regions around the world to limit emissions from vehicles and promote environmental protection. Maintenance and repair of e-cars. Maintenance and repair of internal combustion engine vehicles is an important part of vehicle upkeep to ensure good performance and safety. In general, vehicle owners should have the following maintenance and repairs performed. Oil change. Engine oil should be changed regularly to lubricate and cool the engine. Air filter change. The air filter should be changed regularly to ensure that the engine receives clean air. Spark plug replacement. Spark plugs should be replaced regularly to ensure optimal combustion and avoid engine problems. Brake maintenance. Brakes should be serviced regularly to ensure proper function and safety. Tire maintenance. Tires should be checked regularly for wear and air pressure to ensure optimal driving and safety. Battery maintenance. The battery should be checked regularly for charge level and connections to ensure proper function. For repairs, vehicle owners should consult a qualified mechanic. Common repairs for internal combustion engine vehicles include the repair or replacement of brakes, exhaust and muffler systems, transmission, clutch, ignition system, and cooling system. It is important to follow the manufacturer's recommended maintenance intervals and service requirements to ensure that the car remains in good condition and provides optimal performance and safety. Future of e-cars. The future of internal combustion engine cars is uncertain and depends on various factors. However, There are several developments and trends that indicate that the automotive industry is moving toward alternative powertrains and zero-emission technologies. Electrification. Electric cars and hybrid vehicles are gaining popularity and market share. More and more automakers are investing in the development of electric and hybrid vehicles, as they are seen as a way to reduce emissions and lessen dependence on fossil fuels. Regulations and emissions standards. Governments around the world are enforcing increasingly stringent emissions standards and regulations to reduce greenhouse gas and pollutant emissions. This may restrict the development and commercialization of internal combustion engine vehicles. Technological advances. There are ongoing technological advances in the automotive industry that improve the performance and efficiency of alternative powertrains. This may lead to internal combustion engines being considered obsolete technology in the future. Climate change and environmental awareness. Public awareness and awareness of climate change and environmental pollution are increasing. This may lead to increased demand for cleaner and more environmentally friendly transportation options, thus affecting the market for internal combustion engine vehicles. It's important to note that despite these developments, internal combustion engine cars still play a significant role in the automotive market. Many drivers still prefer the performance and sound of internal combustion engines, and there are many applications where electric or hybrid vehicles are not currently the best option. Ultimately, the future of internal combustion engine cars depends on the development of the above factors and how quickly and successfully alternative powertrains and zero-emission technologies can be introduced to the market. Introduction to hydrogen cars. Cars. Hydrogen cars are vehicles powered by fuel cells that use hydrogen as fuel. These vehicles convert hydrogen and oxygen into electrical energy through an electrochemical reaction, which then powers the electric motor to propel the vehicle. Unlike internal combustion engine cars, hydrogen cars do not emit harmful emissions, producing only water as exhaust. The advantages of hydrogen cars are manifold. Firstly, they offer a long range and fast refueling times, similar to conventional combustion engines. Secondly, they offer an emission-free alternative to gasoline and diesel cars, thus contributing to reducing air pollution and CO2 emissions. Furthermore, they can be produced and operated with renewable energy, supporting the transition to a more sustainable energy supply. However, there are also challenges to the widespread adoption of hydrogen vehicles. One major challenge is the limited availability of hydrogen refueling stations, which can make it difficult to use these vehicles for long distances. The costs of producing hydrogen vehicles are also still relatively high, which means they are currently still more expensive than gasoline and diesel vehicles. Overall, hydrogen cars offer a promising option for the future of mobility and could play an important role in reducing the environmental impact of transport. How do hydrogen cars work? Hydrogen cars operate using fuel cells that generate electrical energy from the reaction of hydrogen and oxygen. This electrical energy is then used to power the car's electric motor and propel the vehicle. The main components of a hydrogen car are: fuel cell stack. The fuel cell stack is the core of the hydrogen car. It consists of several fuel cells separated by a membrane. Hydrogen is fed to one side of the membrane and oxygen to the other. The reaction between hydrogen and oxygen generates electrical energy, which is used to power the engine. Hydrogen tank. The hydrogen tank is where the hydrogen is stored in the vehicle. The hydrogen is stored under high pressure, approximately 700 bar, to ensure sufficient range for the vehicle. Electric motor. The electric motor uses the electrical energy generated by the fuel cells to power the vehicle. Battery. A small battery is used in some hydrogen cars to provide additional power during acceleration. Controller and control unit. The controller and control unit control the vehicle's functions, such as hydrogen consumption, engine performance, and battery charging. When the hydrogen car is started, the hydrogen flows from the tank into the fuel cell stack, where it reacts with oxygen to generate electrical energy. This electrical energy is then transferred to the electric motor that powers the vehicle. The only exhaust gas produced by hydrogen cars is water, making them a clean and environmentally friendly alternative to conventional gasoline or diesel cars. Advantages of hydrogen cars. Environmentally friendly. Hydrogen cars produce no CO2 while driving and only emit water, making them a very environmentally friendly alternative to petrol or diesel cars. Long range. Hydrogen cars have a comparable range to petrol or diesel cars and can be refueled within minutes, allowing for rapid onward travel. Efficient drive. By using fuel cells as a drive unit, hydrogen cars are able to use energy from hydrogen more efficiently than combustion engines. Possibility of storing renewable energy. Hydrogen can be produced from renewable energy sources such as wind or solar power. This allows hydrogen cars to help harness renewable energy and reduce the carbon footprint of the transportation industry. Disadvantages of hydrogen cars. Infrastructure problems. The infrastructure for hydrogen filling stations is still very limited in many regions and can restrict the use of hydrogen cars. Costs. Currently, hydrogen cars are more expensive than petrol or diesel cars due to their complex technology. Energy consumption for production. The production of hydrogen requires a high energy input, which can increase the carbon footprint of hydrogen cars if the hydrogen production does not come from renewable energy sources. Safety concerns. Hydrogen is highly flammable and can be dangerous if handled improperly. Therefore, safety measures and regulations must be observed during the production, transport, and handling of hydrogen. Overall, hydrogen cars offer a promising alternative to gasoline or diesel vehicles, although challenges remain, particularly regarding infrastructure and costs. If hydrogen production can increasingly be converted to renewable energy sources and the infrastructure for hydrogen refueling stations is expanded, hydrogen cars can help reduce the carbon footprint of the transportation industry and support the transition to a more sustainable future. Types of hydrogen cars. There are two types of hydrogen cars. Fuel cell electric vehicles FCEVs. Fuel cell electric vehicles convert hydrogen into electricity, which powers the car's electric motor. Fuel cell vehicles have a comparable range to gasoline or diesel cars and can be refueled in minutes. They also produce only water as emissions, making them very environmentally friendly. Hydrogen burner. Hydrogen combustion vehicles. Hydrogen burners are a type of internal combustion engine vehicle that uses hydrogen as fuel. Unlike conventional internal combustion engines that use fossil fuels such as gasoline or diesel, hydrogen burners burn the hydrogen and produce only water as an emission. However, this technology is still in the development phase, and there are currently very few commercial models of hydrogen burners on the market. Hydrogen as fuel. Hydrogen is an alternative fuel and energy carrier. typically derived from water. It is the most abundant element in the universe and has the potential to play a significant role in combating climate change because, when burned, it produces only water as an emission and does not release greenhouse gases. Hydrogen can be used as a fuel in a variety of ways, including in fuel cell vehicles FCEVs, hydrogen burners, and as fuel for ships, aircraft, and trains. One advantage of hydrogen as a fuel is its high energy density and rapid recharging, making it a promising alternative to fossil fuels such as gasoline and diesel. It also has the potential to play an important role in storing excess renewable energy, as it can be used as fuel for fuel cells or as a feedstock for the production of synthetic fuels. However, a disadvantage of hydrogen as a fuel is that its manufacturing and infrastructure are still under development, and costs can be higher compared to traditional fuels. There are also safety concerns, as hydrogen is highly flammable and requires special precautions during production, transportation, and handling. Overall, hydrogen as a fuel has the potential to play an important role in combating climate change and transitioning to a more sustainable energy supply if the manufacturing and infrastructure challenges can be resolved. Emissions from hydrogen cars. Hydrogen cars are a promising alternative to conventional vehicles with combustion engines because they do not emit greenhouse gases or other pollutants during operation. The combustion of hydrogen produces only water vapor as exhaust gas. This makes hydrogen cars a very environmentally friendly option compared to conventional vehicles. However, there are emissions that can arise in connection with hydrogen production and the development of hydrogen infrastructure. Producing hydrogen from fossil fuels such as natural gas or coal can generate significant greenhouse gas emissions unless low-carbon technology is used. Steam reforming of natural gas. Currently the most widely used method for hydrogen production releases carbon dioxide as a waste product. However, there are also technologies for producing hydrogen from renewable energy sources such as solar and wind power, known as green hydrogen. These technologies use electrolysers to split water into hydrogen and oxygen, with the required electricity coming from renewable energy sources. Green hydrogen has the potential to significantly improve the environmental footprint of hydrogen cars because its production is carried out without greenhouse gas emissions. Another factor that influences the environmental footprint of hydrogen cars is the type of power supply used to generate the electricity needed for the electrolysers. If the electricity comes from renewable energy sources, overall emissions are very low. However, if the electricity comes from fossil fuels, the emissions from hydrogen production can be significantly higher. The transportation and storage of hydrogen also require energy, which can be obtained from fossil fuels. However, there are technologies for producing hydrogen on site that can provide a solution to this problem. One example is fuel cells, which can produce hydrogen from a chemical reaction with oxygen in the air directly in the vehicle. There are also concerns about the safety of hydrogen as a fuel because it is highly flammable. However, there are strict regulations governing the safe use of hydrogen, and extensive testing and research have been conducted to ensure that hydrogen vehicles are safe. Overall, hydrogen cars have the potential to play an important role in combating climate change and transitioning to a more sustainable energy supply if the manufacturing and infrastructure challenges can be addressed. Green hydrogen, produced from renewable energy sources, offers a highly environmentally friendly option for hydrogen cars. Emissions from hydrogen cars. Hydrogen cars are considered a clean alternative to conventional vehicles because they do not emit greenhouse gases or air pollution during operation. When hydrogen is burned in a fuel cell vehicle, only water vapor is released, meaning there are no direct emissions during operation. However, there are other factors that can affect the emissions of hydrogen cars. The production of hydrogen used in fuel cell vehicles can have various emission sources, depending on the method used to produce the hydrogen. The most commonly used method for producing hydrogen is steam reforming of natural gas, which emits a significant amount of carbon dioxide. However, when green hydrogen is produced from renewable energy sources such as solar or wind power, there are virtually no emissions. This is because the electrolysis used to split water into hydrogen and oxygen is powered entirely by electricity from renewable energy sources. Another important factor is the type of power supply used to generate the electricity needed for the electrolyzers. If the electricity comes from renewable energy sources, the overall emissions are very low. However, if the electricity comes from fossil fuels, the emissions from hydrogen production can be significantly higher. There are also emissions related to hydrogen vehicle infrastructure, such as hydrogen transportation and storage. Emissions from transportation depend on the type of transport used to transport the hydrogen, as well as the distance between the production site and